Hey everyone, welcome back to Shazmaths. So today we'll be solving A-Level Mathematics 9709 paper 3-2 which took place on 15th of May 2024. So let's start off with the first question. Sketch the graph of y is equals to modulus of x minus 2a where a is a positive constant. Since we have a positive number outside the modulus, so it will be a V-shaped graph. In order to find the lowest point on the graph, we will equate the value inside the modulus to 0. So x minus 2a should be equals to 0 and x equals to 2a. How do you find the y coordinate of the lowest point? Basically, we have plus 0 outside the modulus, so it will be on the x-axis. How do you find the y-intercept? By putting the value of x as 0, so the graph will be a V-shaped graph. For part B, solve the inequality 2x minus 3a is less than modulus of x minus 2a. First of all, we'll draw this line 2x minus 3a. It will be a straight line which is shown with the black color. Its y-intercept is negative 3a. Now, definitely these two graphs will intersect at a point. In order to find the point of intersection, we will equate the equations of these two graphs. We'll remove the modulus by putting a negative sign outside the bracket and find the value of x, which is 5a by 3. So this will be our point of intersection. So the question says we have to solve the inequality 2x minus 3a is less than modulus of x minus 2a, which means that we need to find those values of x on which the graph of 2x minus 3a is below the graph of x minus 2a modulus. So if we observe closely, if we go towards the left side of this point, the graph in the black line is below the graph in the red line. So the answer should be x is smaller than 5a by 3. Question number 2. Express 6x squared minus 9x minus 16 over 2x squared minus 5x minus 12 in partial fractions. This is an improper fraction because the degree of the numerator and degree of denominator are equal. First of all, we'll factorize the denominator using midterm break and we'll get two linear factors. We'll split the equation into partial fractions, a over x minus 4, b over 2x plus 3 and c. So after taking LCM and simplifying, we'll get this equation. Now, we have to find the values of a, b and c. How can we find the value of a first? By putting the value of x as 4, b and c will be 0. So a will be 4. Then we can find the value of b by putting the value of x as minus 3 by 2. So by putting the value of x as minus 3 by 2, a and c will all automatically be 0. So b should be negative 2. And then we put the value of x as 0 and we'll get the answer of c as 3. So this is my final answer of the partial fractions, 4 over x minus 4 minus 2 over 2x plus 3 plus 3. Moving on to question number 3. The variables x and y satisfy the equation a to the power 2y minus 1 equals to b to the power x minus y where a and b are constants. Show that the graph of y against x is a straight line. So for a straight line, the equation is y is equals to mx plus c. So we need to convert this form into y is equal to mx plus c. So in order to bring the powers down, we'll take log on both sides, LGA and LGB, and according to the property of log, the power becomes the coefficient, so that's why the power, we'll bring the powers down and they become the coefficient. Now, multiply 2y minus 1 with LGA and LGB with x minus y, it will be simplified to this. Bring all the terms containing y to one side and take y as an LG as common. Because of the positive sign, a square and b will be multiplied. How did we get a square? By by bringing 2 up. Okay. Now LG a square b will be divided to the other side, and this equation is now converted into y is equals to mx plus c form. So it is a straight line. Given that a equals to b cube, state the equation of straight line in the form of y is equals to px plus q, where p and q are rational numbers to the simplest form. Okay, so we'll be using the equation from the first part. In place of a here, we'll be putting b cube. So after replacing the values, we'll get lg b cube and b to the power 6 and b to the power 6. So b to the power 6 into b to the power 6 will become b to the power 7. Then according to the property of log, the power becomes the coefficient. So 7, 7 and 3 will become the coefficients. We'll cancel the logs and the answer should be y equals to 1 over x plus 3 by 7. Question number 4. The equation of a curve is y e to the power 2x plus y square e to the power x equals to 6. find the gradient of the curve at the point where y is equals to 1. So we'll be needing the x coordinate as well. So first we'll put the value of y as 1 in the original equation. This will become e to the power 2x plus e to the power x equals to 6. We can make it simpler by making a substitution, e to the power x equals to a. With that, this equation will become a quadratic equation. We'll solve it and we'll find the two answers of a, which are basically minus 3 and 2. Since a was equals to e to the power x, so e to the power x should be equal to 2. We'll ignore the negative value because natural log of negative values does not exist. Now, in order to find the gradient, we have to take the derivative on both sides. Since y is multiplying with e to the power 2x and y square is multiplying with e to the power x, we'll apply the product rule in both of these separately. So, according to the product rule, it will become dy by dx into e to the power 2x plus y e to the power 2x times 2. Then for the second expression, 2y into dy by dx into e to the power x plus y square e to the power x equals to 0 because the derivative of constant 6 will be 0. Now, we'll bring all the terms including dy by dx to one side and we'll bring all the other terms to the other side. We'll take dy by dx as common and we'll shift this bracket here. Now we'll substitute the values and find the value of the gradient, which will give us the final answer as minus 5 by 4. So next question. It is given that the equation e to the power 2x equals to 5 plus cos of 3x has only one root. Show by calculation that this root lies in the interval 0.7 is less than x is less than 0.8. So in order to show, the main method is that we'll bring all the terms to one side and replace them with y. Then first of all, we'll put the value of x as 0.7 in this equation. We'll get the value of y as minus 0.44. When we'll put the value of x as 0.8, the value of y will be 0.69. So since there's a change of sign, so the root lies between 0.7 and 0.8. So that's your first part. For second part, show that if a sequence of values in the interval 0.7 is less than x is less than 0.8 given by the iterative formula converges, then it converges to the root of the equation in part A. So for this case, the simple method is that we'll remove the n plus 1 and n and we'll simplify the equation in such a way that it converts back into the original form given in part A. So I'll take this 2 to the other side. The base of ln is e, so it becomes e to the power 2x equals to 5 plus cos 3x, which is exactly the same equation as in part A. So we have proved it. For part C, use this iterative formula to determine the root correct to 3 decimal places, giving the result of each iteration to 5 decimal places. So we need initial value. The initial value will be this average value of 0.7 and 0.8. We'll put that 0.75 value in this iterative formula. We'll calculate our first value, which will come out to be 0.73759. So in order to calculate the second value, we'll use the first value and we'll put it again back in the iterative formula. The second value will come out to be 0.74094. We'll repeat the process until the values will start to come same. So since the answer required was up to 3 decimal place, so our final answer is 0.740. Question number 6. The diagram shows the curve y equals x e to the power minus ax, where a is a positive constant and its maximum point is m. Find the exact coordinates of m. Since it's a turning point, so the derivative will be equal to 0. So since x and e to the power minus x are being multiplied, so we'll apply the product rule again. It will become e to the power minus ax plus x e to the power minus ax multiplied by minus a. Equated to 0, we'll take e to the power minus ax as common. We'll put both of these factors equal to 0 1 by 1 and we'll find the value of x, which will be 1 by a. Then we'll put this value back in the original equation and we'll find the value of y, which will be 1 over ae. Since the question mentioned exact, that means we'll leave the answers in the form of these fractions. So m should be 1 over a and 1 over ae. For the second part, we have to do integration, find the exact value of integral of x e to the power minus ax from the limits 0 till 2 by a. So this is basically solved by integration by parts. Since we have an algebraic function and exponential function, so u will be algebraic and v will be exponential. We'll take the derivative of u first and integral of v first so that it will help us in our further calculations. So here we have applied the formula for integration by parts. U multiply by integral of v minus whole integral of derivative of u into integral of v. We'll simplify this. We'll put the limits. First of all, we'll put the upper limit 2 by a. We'll simplify, and then we'll put the lower limit 0. If we simplify, the answer will come out to be minus 3e to the power minus 2 plus 1 over a square. So that's my final answer for this part. Again, exact value was required, so I'll leave my answer like this. Question number 7, part A. Show that cos power 4 theta minus sine power 4 theta is equal to cos of 2 theta. Okay. So, we can convert cos 4 theta and sine to the power 4 theta in the form of cos square whole square minus sine square whole square. So this is basically a square minus b square equals to a plus b into a minus b. So we'll factorize using a plus b into a minus b. Since cos square plus sine square equals to 1, so we'll be left with cos square minus sine square, which is equals to cos of 2 theta. So that's our first part. For second part, hence find the exact value of the integral from minus pi by 8 till pi by 8 cos power 4 theta minus sine power 4 theta plus sine square of 2 theta. Sine square of theta, cos square of theta, sorry. So cos power 4 theta and sine power theta will give you, I will be using the value from the first part. We have already proved that cos power 4 theta minus sine power 4 theta is equal to cos of 2 theta. So we have replaced it. So we'll be simplifying the other expression. 4 sine square cos square theta can be simplified as 2 sine theta cos theta whole square, and 2 sine theta cos theta is basically sine of 2 theta. If I open the square, it becomes sine square of 2 theta, and I'll replace sine square with 1 minus cos square theta. So now, using these double angle formulas, I'll be replacing cos square of 2 theta with cos of 4 theta plus 1 by 2, which will help us in integrating. So the integral of cos of 2 theta will give us sine of 2 theta by 2. If we simplify 1 minus 1 by 2, I'll get positive 1 by 2, and the integral of positive 1 by 2 is 1 by 2 theta, and the integral of cos of 4 theta is sine of 4 theta divided by 4. 4 will multiply by 2 to give us 8. So after applying the limits and doing further simplification, our final answer will be minus 1 plus 2 onto 2 over 4 plus pi by 8. Question number 8. The points A, B and C have the position vectors OA minus 2i plus j plus 4k, OB is 5i plus 2j, and OC is equals to 8i plus 5j minus 3k, where O is the origin. The line L1 passes through B and C. Find the vector equation of a line L1. So, in order to find the equation of a line, the first thing we'll do is we'll find the vector BC, which will be OC minus OB. The answer should be 3, 3 and minus 3. The general form is R is equals to A plus TB. So, A is the point on the line, B is the direction vector, so the final answer should be R equals to 5, 2, 0 plus T times 3, 3 and minus 3. The line 2 has the equation R is equals to minus 2i plus j plus 4k plus mu times 3i plus j minus 2k. Find the coordinates of the point of intersection of L1 and L2. So, to find the point of intersection, we'll convert the both of these equations into parametric forms. This is the parametric form of the second equation, this is the parametric form of the first equation. We'll equate the values of x and y. So these are the values of x and these are the values of y. We'll make two equations, 1 and 2. We'll solve them simultaneously to find the values of t and mu. So t is 2 by 3 and mu is 3. First of all, we'll check whether these two values satisfy the values of z. So z values are 4 minus 2 mu and minus 3t. We'll put our answers of mu and t. So we can see here that minus 3 equals to minus 3, so it is satisfied. Now, we can use any one of the value and put it in the form to find the value of the point of intersection. So we'll use the value of mu, we'll put it here, and the answer will come out to be 7, 4 and minus 2. The point D on L2 is such that AB equals to BD. Find the position vector of D. So the length of AB is equal to the length of BD. So how do you find the length of AB? First, you need to find the vector AB. AB is basically OB minus OA. This is your vector AB. BD is equals to OD minus OB. The position vector of D will be using it from the previous part. This one. So OD is minus 2 plus 3 mu, 1 plus mu and 4 minus 2 mu. So BD is equals to OD minus OB. We'll simplify this. We'll find the lengths of these two and we'll equate them. We'll simplify this and we'll get the answer of mu as 30 by 7. We'll put this value of mu 30 by 7 back in this equation of OD, and our answer will be OD equals to 76 by 7, 37 by 7, and minus 32 by 7. Question number 9, complex numbers. The complex numbers z and w are defined by z is equals to 1 minus I and w is equals to minus 3 plus 3 under root of 3i. Express z w in the form of a plus b iota, where a and b are real and in exact form. Okay, so we'll multiply these two complex numbers, we'll simplify this, we'll take iota as common, and this will be our final answer. Express z and w in the form of r e to the power iota theta, where r is positive and theta is in between minus pi and pi, giving the exact values of r and theta. Okay, so for z, we'll find the value of r, which is modulus, as under root of 1 square plus 1 square. It will give you under root of 2. The argument of z will be minus tan inverse of 1 by 1, which will give you minus pi by 4. So the final form of z which is required is under root of 2 e to the power minus pi by 4 iota. For w, we'll take the modulus as under root of 3 square plus 3 under root of 3 square, which will give you 6. In order to find the argument, it will be pi minus tan inverse of 3 under root 3 by 3, which will give you 2 pi by 3. So this is your final requirement of w, which is 6e to the power iota 2 pi by 3. On an Argand diagram, the points representing w and zw are represented by a and b. So this is our point A, this is our point B. We have joined them using straight lines. It will become a triangle. So now we have to prove that OAB is an isosceles right angle triangle. So as far as the isosceles triangle are concerned, we need to prove that two lengths are equal. For point A, we have already found its length in the previous part. This is 6 units. For AB, we can apply the vector approach. AB should be equals to OB minus OA. So we'll apply the modulus formula, we'll find the length. It is also coming out to be 6 units. So since the two lengths are equal, therefore triangle OAB is isosceles. Now using your answers to part B, prove that tan of 5 pi by 12 equals to under root 3 plus 1 over under root of 3 minus 1. So according to the property of argument, if you multiply and take the argument of two complex numbers, there are individual argument will be added. So argument of z and argument of w have been found in the previous part, which is minus pi by 4 and 2 pi by 3. So if we simplify that, it will come out to be 5 pi by 12. As far as zw is concerned, we have already found the expression in the first part here. So if we take its argument, it would be tan inverse of 3 under root of 3 plus 3 over 3 under root of 3 minus 3. We'll take 3 as common and we'll simplify. We can take the tan to the other side and the answer will be proved, which is coming out to be under root 3 plus 1 over under root 3 minus 1 equals to tan of 5 pi by 12. So moving on to the last question, question number 10 part A. By writing y equals secant cube as 1 over cos cube theta, show that dy by d theta equals to 3 sin theta secant to the power 4 theta. So y equals to 1 over cos cube theta will bring cos cube to the numerator, the power will become negative. We'll take the derivative, we'll bring the power down, we'll subtract 1 from the power, and we'll take the derivative without power. After simplifying, the expression will become 3 sin over cos to the power 4 theta. As 1 over cos is secant, so the answer will be 3 sin theta into secant to the power 4 theta. So that's the first part. For part B, the variables x and theta satisfy the differential equation. It is given that x equals to 3 when theta is pi by 3. Solve the differential equation to find the value of cos theta when x equals to 0, giving your answer correct to 3 significant figures. So the first step of solving a differential equation is you need to separate the variables. So we'll shift all the terms involving theta to one side, which has d theta, and we'll shift all the terms to one side involving x, which has dx. So for the left hand side, we'll be using the answer of the first part. Since we know that the derivative of secant cube is 3 sin theta over cos to the power 4 theta, so its integral will be equal to secant cube over 1 over cos cube. For the right hand side, we'll be splitting the fraction into two halves, x over x square plus 9 and 3 over x square plus 9. So 3 was missing from our expression, so we'll multiply with 3 and divide by 3 at the same time, so its integration will become 1 over 3 secant cube of theta. Since the derivative of x square is 2x, so 2 was missing, so we'll multiply with 2 and divide it by 2. After integration, it will become 1 over 2 ln of x square plus 9. We'll take 3 outside the integral. 9 is the square of 3, so this involves tan inverse, so it will become 1 over 3 tan inverse of x by 3 plus c. How will we find the constant of integration? We'll use the values of x as 3 as and theta as pi by 3. So after putting the values, c will come out to be 8 by 3 minus pi by 4 minus ln of 18 by 2. So in the question, we had to find the value of cos theta when x was 0. So we'll put the value of x as 0 in this equation. So it will become 1 over 3 secant cube theta and 1 over 2 ln of 9 plus 8 by 3 minus pi by 4 minus ln of 18 by 2. We'll find the value of secant cube theta. We'll bring 3 to that side. We'll multiply. Then we'll take the cube root. The answer of secant theta will come out to be 1.663. Since we had to find the value of cos theta, so secant theta is 1 over cos. We'll take the reciprocal of the answer. It will come out to be 0.601. So that's it from today's paper. I hope all of you have performed well. Do check your answers, and if you have any queries, let us know in the comment box. Make sure you like the video and subscribe to Shazmaths. See you in the next video.